Hello, everybody. Welcome to this meetup about Servo. First, I'm going to introduce the place. This is a Cacha hub. They do lots of things. I actually have no idea what they do. I'm not from here, but they're very nice people. They do lots of things. Talk with Carmen after the talk, and she will tell you what they actually do. Okay, now I'm going to introduce myself and the group. I'm Albert. I'm from Barcelona Free Software. We have these nice QRs behind of our web, our chat, and our mailing list. Maybe you found us via Mastodon, Twitter, Meetup, whatever. This is a free software. Well, Mastodon is also free software. Whatever. Mailing list if you want to be notified about the events we do. We try to do events once a month, more or less. Also, if you want to do an event, come talk to us, people on the red shirts. We will try to schedule something. Yeah, we have t-shirts for donations. So if you have donations of money, I will donate you a t-shirt. We can speak about that later. And I think that's it. Yeah, that's it. Okay, so Martin is the important person today. He's going to speak about Servo and Rust and web and things. Thank you.
Hello, buenas tardes a todos. More or less, okay. All right. Just get the presentation going. So my name is Martin Robinson. And I'm going to give a presentation today about why we want to build a new web browser engine in, what year is it, 2025? A little bit about me. I'm a partner at Agalia, which is a free software cooperative based in Galicia. And I'm a member of their web platform team, which means that we work generally building web browsers, working on web APIs so that people can write web applications on top of them. And I'm a long-time contributor to lots of different web browsers and browser engines through the years. I've touched most of the open source ones, doing a lot of little things and slightly bigger things, but in general, I've seen a lot of big code bases. Nowadays, I'm working on this project called Servo, which I'd like to introduce. But before I do that, I want to contextualize a little bit about the web browser engine. What is the world of web browsers like nowadays? Because I think it's really interesting, and I think the historical context is actually something that is interesting to study because it really explains like why the software that we're using is the software that we're using. So just to go back to the beginning of the web, this is the story that we've all heard about the first web browsers. There's this man named Tim Berners-Lee, and he wanted to browse a website, and to do that, he had to invent the World Wide Web and to build the first web browser. So he built one called, with a lot of help, called World Wide Web, and this was a browser that was a GUI browser, but it only worked on Next computers. So soon after, the next year, another browser called the Line Mode browser was created, which was cross-platform this time, worked on Unix computers, for instance, but it was text only. And so 2 years later, in 1993, a group of people at a university created NCSA Mosaic, which combined both cross-platform capabilities with graphics. And it included a killer feature for the time, which was images, like really exciting. They probably took a really long time to download for a lot of people, but it was a big step. And really soon after that, it's hard to believe, really soon after that, two new web browsers were made, Microsoft Internet Explorer and Netscape Navigator. And these are the big ones that we'll talk about in a bit. But this actually isn't the whole story. This is the story that we remember, maybe you remember a bit more. But the rest of the story is that during this time, there were a lot more browsers, and there were so many browsers. Everyone was making a browser. It was really cool. And these browsers were made for different reasons. Like some people, like Mac www was obviously made for Mac computers. There were browsers that, like this one, like TK, was like, oh, let's make a browser with the TK toolkit. And all of these browsers would basically do the same thing. They would consume content from the World Wide Web and display it. And it was just a lot easier to build a browser during this time. Some of these browsers were built by literally one person at their house, and some of them were built by giant corporations like IBM. But we don't really remember these browsers anymore because they've all kind of died and they were a flash in the pan. Some of them lived longer than others, but I think this is really cool and something that we've forgotten. But in any case, I left the beginning of the story off with the two big browsers, which I'm sure you all remember, Netscape Navigator and Microsoft Internet Explorer. And these two browsers were the main ones that people started using, and it started something called the first browser wars, which was this intense period of market competition between Netscape and Microsoft. Netscape started out with the majority of the market share, something like 80% of the market share during this time. And the way this battle was fought was with features. So for instance, Netscape introduced JavaScript, which was called, I think, JavaScript just because Java was really cool at the time, so they wanted to kind of like piggyback onto that, that trend, so they made JavaScript. That was back when you could do that without falling into copyright and trademark problems. And then Microsoft made something called JScript, which was their spin on this thing. And also the illustrious marquee and blink tags. I don't know who here has used the marquee or the blink tag? Yeah? Okay, yeah. I'm sure that you feel a lot of nostalgia for those days. It was a simpler time. There was maybe a little bit less fascism in the world. And then a big one, cascading style sheets, which still sticks with us today, along with JavaScript. So what happened at the end of this period? Well, Microsoft won. They used their market dominance to crush Netscape. They gave their browser away for free, which was a cool tactic to destroy your competitors. And they ended the first browser wars with almost 90% of the browser market, which is pretty impressive, like taking on a competitor which has 80% and going to 90%. And essentially, Microsoft had almost complete control of the market for many years. And what happened during this time was that there was one big browser, and Microsoft didn't really see any reason to keep working on the web platform. It was good enough. Internet Explorer was fine. But people were really hungry to make content for the web. The web was a really interesting medium, and download speeds were getting faster, so people were really pushing against the limitations that that the market conditions had set. And what we saw was a lot of innovation in the plugin space. This plugin thing was an API that browsers had exposed, which was incredibly bad. It was a really ugly API that exposed internals of the web browser to like random blobs of binary code. But what it did allow was it allowed animation and interactive content through Flash, which led to, I'm sure you remember this, like incredible amounts of like interesting media, people making weird videos, games, like online games became a thing during this time. And also streaming video through a real player. I mean, the videos were really tiny and pixelated, but you could see video straight on your computer from the internet, which was incredible at the time. And the fact that people used this terrible plugin interface to deliver this content, I think says a lot about how much people really wanted this. But in general, the browser wouldn't give that to you on your own. Like it was something you had to build on top of the browser through the plugin interface. So this situation didn't last forever. A couple things happened in the browser market. One was that AOL purchased Netscape, which in and of itself was part of Netscape dying. But as a consequence of this foundation called Mozilla branched off. And the idea was that, this radical idea that Mozilla was going to work on an open source version of the browser, and then AOL would use that as their browser product. So for a long time, Netscape kind of continued as an open source project inside of Mozilla. But what happened was that there was a group of people in Mozilla who had a different vision for the web. Before, the browser was this big piece of software that maybe included an email client. It was a suite of software, really. And what they imagined was a web-first experience, software that was designed just to consume the web. So they started this project called Firefox, which we know about today. And at the same time, Opera, which was another small browser engine, became freeware, which really reduced the barrier to people using it. And I think it became a more popular and more of an important player in the browser market. Additionally, around this time, Apple took a piece of software called KHTML and forked it to create a library called WebKit. And they did something very unusual for Apple at the time. Someone at Apple convinced them that when they did this, they should really keep the library open source. They didn't have to. KHTML could have been closed sourced into WebKit, but they maintained it as an open source piece of software. And they built their browser on top of that engine, and the browser was called Safari. It was a closed source browser on top of an open source engine, which is a little bit of foreshadowing. And also during this time, a bit later, WebKit was, Google started building a browser on top of WebKit. So this kicked off what we call the second browser wars. And it was a lot different than the first one. In general, as time went on, the browser engines, not necessarily the browsers themselves, but the engines, the software that ran so like inside a browser you have the tabs and the menus, but then there's like a box inside with the web content. That stuff inside the box is basically the purview of the web engine. That part was open source, but then the companies that made browsers would often build a closed source browser on top of that engine. And the other thing was, standards became a lot more important. During the first browser wars, features were just added to browsers without with very little standards involvement, maybe with the exception of cascading style sheets. And also, finally, the web platforms started to grow to contain all of the enthusiasm that people had for building things for the web. It started to gain this backlog of features that were necessary to produce the content that already existed. So essentially, the web platform was basically just growing to make plugins obsolete. This included things like HTML5, a version of HTML that included everything people were using, and a lot clearer instructions on how to process the HTML, like what to do when there's an error in the markup, that kind of thing, which those things didn't exist before. And I've mentioned here CSS 2.1, which maybe it's odd that I mention a minor version, but the interesting thing here, and I think it says a lot about the stagnation, was that this 0.1 release came decades after CSS 2. For decades, they didn't release a 0.1 release. And during this time they did. They finally were like, okay, we're going to keep working on the standard that we basically abandoned. Transforms, transitions, animations, WebGL, audio, video, this all happened just in a lightning flash as soon as the second browser war started. And like I said, because the web platform started gaining these features, plugins became obsolete software, they became security concerns, and they started dying pretty quickly. Even to the point where when the iPhone was released in, what was it, 2008, something like that? Apple said, we're not going to support plugins on this device. I remember this moment, like during that time where there was a security vulnerability in Flash, and because Flash ran on everything, like including TVs, and the vulnerability affected like every computer, like every platform, your TV, lots of like phones even that were running Flash. So the death of plugins was actually like probably a positive move for the web now that it had these features. And then what happened? At the end of the browser wars, as we know, Chrome won. Chrome is the most popular browser today. It has 65% of the market share when I made this slide. And no other browser has 20% of the share. This is a bit like deceptive as well because a lot of people use iPhones and the iPhone can't run Chrome. So that is like a limitation on how big Chrome can be, how much dominance Chrome can be, as opposed to the massive dominance that Internet Explorer had at the end of the first browser wars. In addition, most browser vendors aren't just companies that make the software we call a browser. They are service providers. They have their own suite of services, their own cloud software. I mean, it's the case with almost everyone, including Firefox, which has some services that they provide. And the other thing is that we have this conception now of not just the browser, but the browser engine. And what does this software look like? It's generally speaking open source. And the browser that's built on top is closed source. And I suspect that's because these browser vendors are service providers. So like, it doesn't make sense for them to open source the software that they sell their services with. But the thing inside is so complicated and legacy that it is open source, it stays open source. The software is written in C++, Objective-C, nowadays very small amounts of Rust and other minor languages. And it's, like I said, they're legacy software. So big changes to the software are both expensive and risky because changes might lead to situations where you're going to lose a tiny performance margin that you worked really hard to get. And the other thing is that in the standards bodies, these companies that work on browser engines are the gatekeepers of new standards. If you don't make a browser engine, it's a lot harder to push for your standards desires in the standards bodies than if you are a browser vendor or if you have allies at the browser vendor companies. The other thing is that browser engines are an endangered species. There used to be a lot more. For instance, there was Presto, which is the Opera engine. That was abandoned in 2013. There was Trident, which was the Internet Explorer engine. That was abandoned in 2015. And there was Edge-HTML, which was an effort to replace Trident in Internet Explorer. And that was abandoned in 2020. So essentially, there are 3 major ones left: Gecko in Firefox, WebKit in Safari, and Blink, which is the engine that runs Chrome and Internet Explorer in Edge. Is that what it's called?
Brave.
Sorry?
Brave as well.
And Brave as well, yeah. So in general, there's less every year. People are wondering, like, when is Gecko going to disappear? Hopefully never, but maybe next year, who knows? I also want to talk about a very special moment during the second browser wars. And it was this. This is browser market share. And there's this really cool point where like these 3 browsers had almost an equal share of the browser market, which I think corresponds pretty closely to when a lot of this innovation was happening. It didn't last for an inordinately long amount of time, but it was a very special moment. And all of this time in here was like when a lot of the big changes were happening. And I often ask myself, how can we get back to this time when there was so much competition and people were taking risks and doing really interesting things with the web? Is the web over? Is there something new that we can do with it? And my answer to that question is, we can build a new browser engine. That brings with it a lot of interesting benefits. For example, with a new browser engine, we can prevent the complete control of standards bodies by a small number of browser vendors. If there's a new engine, we can come to the standards as engine developers, and we can say, like, this is what we think. This is what we think the web should look like. And if we have an engine, it's a lot more convincing than if we're just random people. The other thing is it offers a place to innovate. In general, if you want to put a feature in a browser engine, you have to go to Google or Apple and you have to convince them that, okay, this is a feature I want to work on, I want to put it in the browser engine. And generally speaking, the answer is no, we don't want that. We don't need that for our business. So you can do that on your own, but you can't check it into our source code. So a new browser engine lets us have a place to build this experimental web technology that maybe isn't interesting to giant corporations that sell you ads or whatever they sell you. The other thing is new platforms. In general, browser developers only develop for the platforms that they're interested in. So for WebKit, Apple only works on Apple devices. They used to work on a Windows port, but that's gone. In general, it's just Apple devices. There are WebKit ports for other platforms, but that's done by other people. Google works on a lot of them, but if you have like a new hardware or software platform that you want to run it on, good luck convincing them to let you work on it inside their source code. And the final thing is new web technology. Like I said, if you want to build a new web platform API, it's going to be really difficult to do it inside other browser engines. But if we had our own browser engine, we could build that experimental technology, and we could figure out if it's interesting and if it can change the world. So I often think about what the ideal browser engine is like, and I think it boils down to a few core ideas. One is that it should be independent. It shouldn't be owned by a big company. It should have input from a lot of different people. It shouldn't be like centered in one particular country. It should be international. The other thing is it should be safe. The browser engines today are written generally in C++, which has a lot of problems with memory safety. We have languages today that prevent those problems. So if we build a browser engine, we should use them because it's really important that the browser doesn't have security vulnerabilities. Because you probably all look at your bank account in your browser engine now, and it'd be great if your browser didn't give people your bank account, I think. Seems good. The other thing is it should be concurrent. The processors that we use today have a lot of cores. They're built for spreading the work out through those cores. And in general, browsers, like I said, they're legacy software. They were written at a time when there was one core, and it was really difficult to spread the work. And also, C++ isn't a great language for doing that in an easy way. The other thing is it should be embeddable. What this means is you should be able to put the browser in an application that's not just a browser. There are lots of applications that need a web view, essentially, and our software should allow for that use case. And finally, it should be modular and it should be lightweight. It should use reusable components that could be used by other software because we're good open source citizens, and it should be lightweight, which means that it shouldn't be this massive piece of software that takes up all the memory. So for me, that's Servo, which is basically an embeddable, independent, memory-safe, modular, and parallel web rendering engine. And to talk about its independence, I want to describe its history a little bit. It was made in 2012 as a research project at Mozilla, essentially experimenting with using Rust to write a browser engine. In 2020, Mozilla stopped working on it, and it became a project of the Linux Foundation. And then in 2023, it moved to Linux Foundation Europe. Everything in Servo is run by the community. Decisions are made by a committee of people from the community. Some of us work for companies, some of us are just random people who are really interested in Servo. But in general, no one company is making all the decisions for the project. And it's safe. Servo is written in the Rust programming language, which means that built in to writing the software are memory safety guarantees that Rust provides, that are provided at compile time to help us prevent writing errors in our code with memory. This is ensured by the borrow checker and the ownership system in Rust, which I'll talk a little bit about. And it has built-in concurrent data structures. What this means is the idea of spreading work through the different threads is built into the type system that Rust provides. And it has lots of API data structures that are used to help make this possible. With these tools, we can avoid use after free and data races, some of the biggest problems in web browsers today. So, how many of you have used Rust before? Yeah, it seems like, yeah, a few. So you're familiar with this. So I'll just run through this just so you know what's going on here. So essentially this is the main function of a Rust program. I've declared a variable. It's an integer, which is determined automatically by the compiler. And I am taking a reference to this, two references to this variable. A reference is kind of like a pointer, if you're familiar with C++. It's just like referring to a variable which is in another piece of memory. And this works. This will print 42 twice. So that's totally possible. What if we modify our program a little bit? So now what we've done is, in general, I should say, by default, all variables in Rust are const, which means that they can't be modified. They're the same value. But if we put mut in front of the declaration here, that means that the variable is mutable. We can modify it. And the first reference I took this time is a mutable reference, which means that like I have a pointer to the variable, and I can change the contents of the variable with my reference. And then I take an immutable reference as well. So what happens when I do this? The compiler refuses to compile the program, which is a very common thing when you're working with Rust. At first it feels very frustrating, but then you realize the compiler is just looking out for you, maybe like a parent or a concerned adult. And what it says here is that I cannot borrow a variable as a mutable, which is what I'm trying to do here in this line, because I have already borrowed it as mutable. And if you think about this a little bit, it makes sense. I should only be able to change the variable from one place. Otherwise, two places might be trying to change it at the same time. And this really comes into play when you're dealing with threads. But it also means that that these pointers don't. There's not two mutable references to one variable in the system. So with these tools, we essentially get zero cost safety. Normally what happens with this type of thing is these checks happen at runtime, which means that we have to pay some penalty to make sure that the variable is writable, it's fine to write to it, and if not, we produce an error. But with this, the compiler is tracking this ownership, and this tracks through, like, these track through calling functions, storing the variables into different places. Like if I stored these references, I could only store one mutable one, or any number of immutable ones, const ones, because it's fine to have lots of different views of memory that doesn't change. But we don't pay any penalty for this because it's all paid during the compilation process. So I want to talk a little bit about concurrency as well. Like I said, our devices today have a lot of different cores, and usually when you lay out a page, the browser is pretty good about using your different cores for different kinds of activities. It can maybe like paint on one, Canvas can sometimes run on a different core. But when it comes to laying out a single page, that happens on one core. So it's a serial process where you walk down the page, you look at the DOM, you combine it with the CSS, and you lay out the page. And then maybe you send it to be painted. But figuring out where all those elements go, that has to happen serially. Servo is different in this way. It has a parallel layout, which means that if you think of a DOM, it's a tree. And in general, the requirements for laying out an element, they move upward. So like, I know how to lay out one div, and then I send all those laid out divs to its parent, and its parent can like position them inside itself, apart from a few small things that don't follow this model, which means that we can essentially use Rust's concurrency mechanisms to process the DOM parallelly, and then stitch it together at the top when we have all the children laid out. And Rust unlocks this parallelism through its fearless concurrency. And this capability is unique to Servo. Other browsers don't do this. It's too hard to take a C++ data structure and to make it parallel across different cores while maintaining safety, memory safety. But the compiler in Servo really helps us with this. And so here's a really simple example of how this works. We're going to talk a little bit about our multiple mutability thing that we were looking at before. But essentially what we have here is we've defined a structure, which is just a data structure in Servo. This data structure contains one value, which is an integer. And we declare a mutable version of this structure. Structure is the name here. With the value of 100. And what we do is we spawn a thread. And this stuff here, this is all anonymous function. So this is like a function call. And this function will run inside of the thread. So this is like in a different thread, all this stuff. And then this is the end, which is running in the same thread. So this thread spawns somewhere else with this, and then we print this. But you can kind of see the issue here, right? Because we've declared a mutable structure and we've sent it into the thread where it's being modified, and we try to print it in both in the thread and outside the thread. And indeed, Rust is like, you can't do that. You can't modify this value. It's already been moved, something called move semantics, into the thread. So if you try to modify it outside, it's just not going to work. You don't own it anymore. And you can see why this is really helpful, because if we move like an element into a thread in Servo, we know that it can't be modified outside the thread until it's laid out, and we get the results back. And the compiler tells us that we're doing things correctly. So how would we rewrite this code to work properly? Well, what we can do is very similar to before. We move the structure into the thread, so now it belongs to the thread, and then we return it from the thread. So we're moving it back out. And then here, we wait for the thread to finish, which is this join, and we unwrap it because it returns a result in case it fails. We unwrap it and we get the structure back out. And then we can print the structure. And this works properly. So you can see how these kind of capabilities make it a lot safer to split up work between different threads without worrying about writing on the memory of a different thread. If you've ever tried to do threads in C++, this happens all the time. It's like a thing that you just constantly do. You accidentally write on the memory of something. It's in a different thread. You get memory errors. It crashes in a different way every time. It's horrible. In Rust, this just doesn't happen. And what we call this is fearless concurrency. Essentially, it's fine to try this. You don't have to be scared because the compiler has your back. And indeed, when we're writing Servo, the compiler has our back when we make these changes. I'd also like to talk a little bit about what it means to be embeddable. Our goal at writing Servo is to be embedding first. We're not trying to be an engine, we're trying to be an engine. But we'd like to be embedding first, which means that we're not just a browser, we're a library that you can use to build an application. And that's any kind of application, like a browser, or like an application like an Electron application, or just something that needs to display web content. A lot of applications need this nowadays. Ebook readers, Markdown viewers, almost anything you build today, it's quite possible that you need to show some rendered text. And the browser engine is the obvious thing for this. So our goal is to be something you can reach for to build this kind of software, which is not really the case with other browser engines apart from probably WebKit. We also want to be modular and lightweight, which are two different things slightly, but related. Servo is composed of different reusable Rust components, libraries, crates we call them, and many of them are available on crates.io, which is essentially the library repository that Rust uses. So you can take parts of Servo, you can integrate them into your project without having all of Servo. For instance, we have a style engine, and if you want to just style a DOM, you can do that without having the rest of the web engine. And indeed, many parts of Servo are already used in Firefox. For instance, like I said, the style engine is a part of Firefox, and we share that code. And it's also available to people just who want to write their own software. Components can be rewritten and replaced. Servo's software, Rust software ecosystem makes this a lot easier with crates. And in general, we're always looking to reuse code that's written by open source developers, and we also like to give back to the open source community. Our code base is a lot newer. We are over 10 years old, but that's actually pretty young for a web browser in the end. And it also means that it's a lot easier for us to make big architectural changes. In the past year, we've almost finished writing the features of the new layout engine, which is basically a drop-in replacement of the old one. And this kind of effort is a long process in other browsers. In fact, I think only one browser has completely replaced its layout engine, which is Chrome, and that's because they have $1 billion. So, in summary, what we want to do is we want to create an independent and advanced browser engine that disrupts the web platform. We want to go back to that moment when there was intense competition and the web platform was exciting and adding a lot of new features that actually helped people. That's what we envision for the web. And we also want to build a community of developers that's vibrant, active, and is full of people who are curious, and also love to tinker or just want to work on a web engine. So our goal is to do that by becoming welcoming and to become easy to join. So with that, if you are interested in trying out Servo, you can go get an experimental build on our website, servo.org. And you can also get in touch with us on Mastodon. We're also on Blue Sky now. GitHub, we use Zulip, so you can come join our chat channel, or you can email us at join@servo.org. And thank you very much. Does anyone have any questions? I saw a hand here first. Yeah. Is the cord long enough? Yeah.
Thanks for the presentation. I had a question regarding the move to the Linux Foundation Europe. And also I heard of a project called Verso, which branded itself as the European browser. Is there any connection at all, or is this just coincidence? And then what does this mean for, I guess, the objective to become a global browser when you are part of the Linux Foundation Europe?
That's a great question. I think the move to Linux Foundation Europe was mostly for convenience, because most of us working in Servo are in Europe. Well, I mean, we're all over, but so Agalia has a lot of people working on Servo. We're in Europe, and it just made it a lot easier to deal with people in the same time zone, same currency, those sort of things. I'm not totally versed on what the other benefits were. It's all kind of businessy stuff that I'm not as familiar with. With regard to Verso, it's a browser, it's an experimental browser built on Servo. The people who work on Verso also work on Servo. We're working together now to build this new embeddable embedding API, and it's we love it when people build software with Servo, so it's great. It's great to see it. I'm not sure why they call themselves the European browser, but I think it's a great idea. So, a question here? I think I saw this hand first before.
So you mentioned that Firefox uses parts from Servo. How does that work, right? Because to me it sounds strange that you can use parts of Servo. Like either you use Gecko or you don't use Gecko. How does that work? Which parts?
Sure. There are two major components that Firefox uses. I think maybe it's more accurate to say that Servo shares those components with Gecko. Gecko does a lot of, the people who work on Gecko do a lot of work on those components, and we also, but the balance is maybe more toward Gecko. The two major components are the style system, which was originally a part of Servo, but it was so much more performant than Gecko's old style system, that it became integrated into Gecko as well. And this is the system that where you essentially, you give it a style sheet, it parses the style sheet, you give it a view into a DOM, and it combines those two things. So it does selection, like if you write a style selector, it figures out which elements those apply to, it does cascading, all of those things. So at the end, you can say like, go to an element and say, what's your style? And it will tell you the answer to that. The other part that we share with Gecko is something called WebRender, which is a graphics rendering engine. And essentially what this is you can give it a display list, which looks a lot like CSS. You can say like, this is a box, this is a border, this is a drop shadow, this is a transform. You give it this is some text with a font. You give it a whole list of items, and it renders it to an OpenGL context, which is a very complicated process. So essentially, we gain all the benefit from that work as well. Did I answer your question?
And those are Rust.
Yep, those are both in Rust. Yeah. Okay.
Thanks for the insightful talk. I have a question about whether Servo has implemented all of the web standards or all of the web APIs, or to what extent it's implemented them, or, for example, like the WebXR API. And more broadly, what does Servo mean for like 3D on the web?
Yeah, so in general, our goal right now is to we have not implemented support for all web APIs. There's a lot of them. I think there's like kind of two efforts in Servo. One is to kind of get the basics, which is that we're almost done with like CSS 2. We have a lot of CSS 3. So like that part is kind of coming up from the bottom. And then we also have some support for, well, actually a good deal of support for more experimental APIs. Like we do have support for WebXR. We have growing support for WebGPU and WebGL. And really it's just a question of finishing that. What we're lacking is a lot of things in the middle space that maybe you've never heard of unless you've had to use them, like something called an abort controller. This is a thing that like almost all websites nowadays use, but like I've never heard of it until I saw that we were missing it. So we miss a lot of these little things that you need to run complex websites nowadays. But yeah, we have the advanced ones and the ones from the bottom. That's the main thing. But we're trying to finish. It's a lot of work. I think I saw a hand here.
This is the same question.
The same question? Oh, great coincidence.
So, can you build everything you build in Servo without using unsafe Rust? And if you start using unsafe Rust, doesn't that fearless concurrency becomes fearful concurrency?
Again, a great question. So right now, you can't build everything in a web browser with safe Rust. There's one big thing that's missing, and that's the JavaScript engine. And essentially, this is because JavaScript engines compile. So it used to be in the past that JavaScript engines would just interpret JavaScript code, which would be fine. You could do that in Rust, no problem. But nowadays, what they do is they compile the JavaScript code to machine code and write it into memory and then execute that machine code, which is something you can't do with safe code because you're executing data sections. So like what we do instead is we're actually reusing SpiderMonkey for the JavaScript part, and that interface with SpiderMonkey, and in general interfaces with any C libraries that we have to use, which is because you have to talk to the system, you have to interface with C libraries. Those are the unsafe portions. But the great thing about Rust is that when you use unsafe code, you surround it lexically with curly brackets. And the unsafe stuff is only in there. And it means that you only have to audit those bits that are inside the curly brackets. And it makes it a lot easier to reason about the safe parts that are outside. And the more you decrease the things inside those curly brackets, the less unsafety you have to worry about. But in general, there is that barrier, that boundary between the safe and the unsafe. So those things do happen. I would say that like most of the issues we face are not because of mistakes we're making in unsafe code. In general, it's logic errors. I see a hand here.
Yep, I can go ahead. How easy is to build Servo? Like, if you try to build, like, I don't know Firefox, but if you try to build Chromium, like, you will die, right? It's like, it takes a lot of time. You need like 64 gigabytes of memory because it starts linking and it eats all your memory. It's very complicated. Like, Google doesn't like providing packages, so you have to go to Git and use like their own Git tools to build. Like, if I want to build Servo, like, will it take me a day or a month?
It'll probably just take you a day. So in general, Servo is lighter than other browser engines. We aren't quite as easy as a normal Rust package where you can clone the repository and run cargo build. We're not quite there. We're getting there. We want to be. But in general, it's a question of running like a bootstrap step and then compiling. And it's still pretty hefty. And that's just because when you generate all of the stubs you need, this is like most of our code, like line-wise. What you do is when you make stubs of code that are executed by JavaScript, you need all this glue to connect the JavaScript world to the native code world. And for us, that's hundreds of thousands of lines of code. So when you compile this part of Servo, it takes a while. Everything else is lightning fast. We're working on making that better, but I would say that in comparison to Chromium, it's a lot better. It's a lot better. Hand here? Sorry. Go through, okay. Yeah.
It's kind of piggybacking on his question again. So there's a web page test that is like the test suite for web platform features. I looked on the website, it's not there, but I guess somewhere internally you run this. Can you give us an estimate? Like, is it 10% that you reached, 20%? 80%?
Yeah. I don't know if I'm connected to the network, but if you go to wpt.servo.org, you can see the results of our WPT tests. Right now we pass about 60%. It's a little deceptive because millions of those tests are testing one feature of the web, which we don't support yet. So our results should go up quite a bit when we add that feature. But in general, you can take a look at different categories of things. And we're always like tracking essentially those, making sure those graphs are going up. Any other question? A question in the back here.
Maybe you can add some words about like performance-wise, like related to other browsers. Or?
Yeah. So right now, the performance question is a bit of a mixed bag. Other browsers have had years of engineers pounding away on them to squeeze the absolute most out of these legacy engines. So what we have is essentially a new architecture, and we're rebuilding the layout system, which means that we first get the features and then we try to make them performant. And in general, what we're missing right now in our layout system is something called incremental layout, which I think we're hoping for this year. And what this means is that when a page changes, you don't lay out the whole page again, you just lay out the portion that changes, which is a trickier problem than it sounds, but without that, it's hard to directly compare the performance to other browsers. even so, if you just look at a full layout, in some cases Servo is faster, which I think is amazing considering how few of us there are working on it. And in many cases it's slower just because we haven't had time to optimize some of those things. But the thing is, we always have this knob that we get to turn that other browsers don't, which is the parallelism. We can put as much parallelism into any process in the layout as we want, and we can tune that. And other browsers don't have that option. All they can do is optimize their code, which is something that we can do as well. It's just that we haven't gotten to that point yet. We're still finishing the main bits of layout. Question here?
I have two very unrelated questions, but one is the team. I'm curious about the team that's building Servo, like how many are, what kind, how do you work? And the second one is, besides browsers, you mentioned like there are a lot of other applications. Do you know of initiatives or applications that are already built that can leverage what already is there from Servo to something, I don't know, like, I'm thinking of applications like desktop Atom style or editors, embedded, that embedded web browser, things like the Tauri platform.
Yeah, great question. The team, there's a group of us at Agalia, about 5 or 6 people. In addition, there's maybe 10 or 15 working for different companies, just on their own, volunteers, scattered throughout the world. And we all collaborate together to build the software. Regarding applications, I would say right now, an example of something that Servo could be useful for would be something pretty static like signage. We're still working on, there's actually a big piece of the web platform that you don't think about that much, which is editing, which is a huge mess. Once we get that in place, it'll be a lot more useful for interactive applications. And that's another goal this year, along with interactive layout. But I guess I could also say something that I didn't mention before, which is that, one moment, let me unlock my laptop. I gave this talk in Servo. So these slides are running in Servo. So yeah, like if you can imagine something like this, then you could use Servo for it. Any other questions? Well, if not, thank you so much for your questions. It's been great, and thank you so much for listening to my talk.